So let's look at this second example of a Kc equilibrium problem that you could encounter. Now, in this case, let me just go to um, my screen here. Okay, so the question gives you a balanced equation, gives you the Kc value, and you're starting off with 0.500 moles of iodine and of H2. And the question is asking how many moles of each gas will be present at equilibrium. All right. So let's get started. Let me move to my sketchbook right here. I already started doing this problem, so I'm just going to go through the steps that I've started off already. So what we're going to do first is determine the concentrations of both the H2 and I2. And because the moles and the volumes are the same for both gases, it's basically the same calculation. And that's what I'm showing right up here. All right, the concentration of I2 and the concentration of H2 will be equal to the moles of each of them divided by the volume because they're in the same container. So this would be the concentration for both H2 and I2. The next thing I'm going to do here is show you the ice table that I have set up here. So we have H2 plus I2 to give you 2HI. And the initial concentrations of H2 and I2 are shown here because we calculated them up here. And then we have to figure out the changes. Now, we don't know what the changes are. So what I've done is I've decided that the change of H2 would be X, minus X, right? If that is true, then the change in I2 would be minus X as well because of the 1-to-1 ratio between these two. And because of this 2 here, the change of HI would be plus 2X. Plus because it's being produced, and 2 here because you have a 2 here, which indicates that for every 1 mole of I2 that reacts, 2 moles of HI is produced. So at equilibrium, these are the equilibrium concentration terms that we have down here, right? And basically from here, the aim is to solve for X. Now, how do we do that? Well, we write down first the Kc expression for the reaction, which is given here, concentration of HI squared divided by concentration of H2 times the concentration of I2. And we already know that that is equal to 54.3 because that is given right here, right? So what I've done is going from here to here is plug in the different terms for these concentration terms from here into this equation. I ended up with this equation right here. And this would be equal to, again, 54.3. All right? So basically from here, it's algebra. We have to solve for X. And from the look of things, the best way to do that is to find the square root of both sides. And that simplifies to 2x over 9.52 times 10 to the minus 2 equals to the square root of 54.3, which I already did the calculation for that. That works out to be equal to 7.37. All right. Now, I won't show you all. Oh, by the way, this should be a minus x here. This is a minus x. Okay, now I won't show you all the terms or all the steps involved. I'm just going to show you that x, when I worked it out myself, x turned out to be equal to 7.49 times 10 to the minus 2, right? So, to find out what the concentration of H2 is, that would be equal to the concentration of I2 at equilibrium, which is equal to 9.52 times 10 to the minus 2 minus 7.49 times 10 to the minus 2. And according to my calculations, this works out to be equal to 2.03 times 10 to the minus 2. And as far as the concentration of HI is concerned, that is equal to 2 times X, which is 2 times X, which is 7.49, times 10 to the minus 2, which works out to be equal to 1.50 times 10 to the minus 2. All right? So these are the concentrations of everything at equilibrium. But we're not done yet because the question is asking for the moles. So I need to create some space here. So let me erase this part right here. Okay, I think this is clean enough. Okay, so the moles, whoops, go back to my pencil function here. So the moles of H2 will be equal to the moles of I2, which will be equal to the molarity, which is 2.03 minus 2 m multiplied by the volume of the vessel, which is 5.25 liters. So 2.03 times 10 to the minus 2 times 5.25. And according to my calculation, this works out to be equal to 0.107 moles. And then the moles of HI would be 1.50 times 10 to the minus 2 m multiplied by the volume, which is 5.25. Whoops. Let me go to my eraser here. Erase this out. Back to my pencil. Okay, so 5.25 liters. And let me do that calculation on my calculator. 1.50 times 10 to the minus 2. Whoops. 1.50 times 10 to the minus 2 times 5.25. And according to my calculation, this works out to be equal to 7.88 times 10 to the minus 2. And that's it. So these are the answers that the question is asking for. Okay. All right. So that's another example. I think I have some other examples coming up. So that's it for now.